Welcome to This Explainer. Today, we're diving into a literal game changer for global cybersecurity. We are standing right on the edge of a massive technological shift. The way we protect everything, and I mean everything, from your personal text messages to top-secret military intelligence, is about to change forever. We're moving out of an era of mathematical complexity and stepping into a world governed entirely by the absolute, unbreakable laws of physics. It's a fascinating pivot, and we're going to break down exactly how the whole shebang works. Think about this for a second. What happens when the complex math protecting your bank account and even military secrets just becomes completely obsolete overnight? For decades, our entire digital world has been secured by really complex math problems. When you log into your bank, a normal computer would literally take thousands of years to guess your password or encryption key. But here's the massive problem we're facing. Future, super powerful quantum computers, they'll be able to solve those exact same mathematical problems in mere seconds. So the standard encryption we rely on every single day is on the verge of becoming totally useless. The big question is, how on earth do we defend against this? So here's our roadmap for today's explainer. 1. The quantum hacking threat. 2. Physics over mathematics. 3. India's QKD deployment. 4. The global quantum race. And 5. Future-proofing our data. Let's jump right into part 1, the quantum hacking threat. Right now, we're at a critical crossroads. Currently, we rely almost entirely on math-based encryption. It uses equations that are super hard for standard computers, but like we just talked about, a quantum computer will slice right through them. That glaring vulnerability is exactly why scientists are basically abandoning math and pivoting to physics-based encryption, specifically a technology called quantum key distribution, or QKD. Instead of relying on a math problem that might get cracked tomorrow by a smarter algorithm, QKD transmits the encryption key using individual particles of light, photons, and these are sent through an optic fiber cable. This means the data is protected by the immutable laws of physics. Unless the fundamental laws of the universe suddenly change on us, your data remains secure. Moving on to part 2, physics over mathematics. So let's look at how this scientific magic actually protects our data. The absolute crux of why this technology is completely unhackable comes down to something called the observer effect. It's closely tied to Heisenberg's uncertainty principle. Now, according to quantum mechanics, the very act of observing a quantum particle instantly changes its physical state. You literally cannot look at a photon without fundamentally altering it. This isn't just a fun theory, it is a hard physical law of the universe, and it provides the ultimate burglar alarm for our data. Let's map out a real-world hack attempt to see this in action. First, an encrypted photon key is sent through an optic fiber cable. When a hacker tries to, tap that cable to observe the photon and steal the key, that observer effect triggers immediately. The photon's physical state changes the precise millisecond it gets looked at. The system instantly detects this alteration, knows a hack is occurring, and just discards the compromised key before any actual sensitive data is ever sent. It's an incredibly elegant, foolproof defense mechanism.
All right, part 3, India's QKD deployment.
With that scientific foundation laid, let's explore how this is actually being utilized out in the real world. We've coasted in the standard encryption era for decades, right? But as the quantum threat started looming, nations had to act fast. Just look at the rapid progression here in India. In 2022, the DRDO successfully tested a highly secure QKD link over a distance of 100 kilometers. That is a massive technological milestone. And incredibly, by 2024, the Indian Army actually began actively deploying these systems. I mean, they went from successful testing to real-world military deployment in just a couple of years. Now, this rapid advancement isn't happening in a vacuum. It's driven by a highly collaborative ecosystem. You've got heavy hitters like the DRDO and the Indian Armed Forces actively deploying these links near critical borders, and they're working right alongside the Department of Science and Technology. Plus, you have agile private startups in the mix, like QNU Labs. This unique blend of government, defense sectors, and nimble startups is pushing India's quantum capabilities forward at a seriously impressive speed. To keep that momentum going, the government threw down a massive financial commitment. 6,000 crores. This is the financial backbone of the newly launched National Quantum Mission, or NQM. It's a huge strategic investment that clearly signals just how seriously India is taking this shift toward quantum tech. So what exactly does 6,000 crores buy you? Well, a primary goal of the NQM is to dramatically scale up the QKD network, Currently, as we mentioned earlier, the secure links are working around the 100-kilometer mark. The mission aims to stretch that to a staggering 2,000 kilometers by utilizing satellite technology. This is all about taking a localized security tool and turning it into a nationwide, completely unhackable communication grid.
Which brings us to part 4, the global quantum race.
Scaling up is absolutely essential because other nations definitely aren't standing still. India faces a very specific challenge on the global stage. Right now, India uses the optic fiber method, which is fantastic, but the light signal naturally degrades after about 100 to 150 kilometers. To cover the whole country, India basically has to build complex quantum repeaters or move entirely to space-based systems. Meanwhile, China, who is widely recognized as the world leader in this field, has already launched the Mischius satellite. They are beaming a quantum key straight from space to the ground to create an unhackable link that spans thousands of kilometers. So India is in a dead sprint to overcome its distance limitations to match and eventually exceed these global benchmarks.
And finally, part 5, future-proofing our data. Why does this global race and all this complex physics actually matter for national stability? Well, it basically boils down to 2 huge strategic impacts. First, unhackable military links. By using QKD, armed forces can ensure that highly sensitive information, we're talking top-secret launch codes or critical troop movement orders, are mathematically and physically impossible for an adversary to intercept without instant detection. Second, future-proofing the economy. As banking and financial transactions transition entirely to digital platforms, protecting that financial data from future quantum attacks is critical. QKD provides that ultimate, unquestionable layer of trust for our money.
Okay, before we wrap this up, let's lock in the key takeaways. Whenever you think about the future of cybersecurity, remember these 4 pillars. Quantum key distribution, or QKD, is the method. Photons are the vehicle. The observer effect is the physical law acting as our unhackable alarm. And the National Quantum Mission is the initiative driving it all forward. If you have those 4 concepts down, you thoroughly understand this massive technological shift. I want to leave you with this one final provocative thought. If our entire digital world, our secrets, our money, our national defense, is secured by fragile math today, math we know for a fact will soon be broken, how fast must we race to lock it behind the immutable laws of physics tomorrow? It is a race against time, and it's a race we absolutely cannot afford to lose. Thanks for joining me on this explainer.